Hello students. Today we will be starting our modeling unit, but before we do, let's review some of our graphing of exponential and log transformations. So note the first one is an exponential, right? Don't forget that the base is 3. A is -2. Up in exponential land, I have something happening to x. Which means I go left 2. Right? So remember, for us, you're always taking the initial point 0, 1 and 1b and telling me what happened to it. So remember, the only thing happening to x is c. So each x coordinate is going left 2. And a is a multiplier on y. So you're going to multiply every y times -2 times -2. Also, don't forget about the horizontal asymptote. Remember, there's always a horizontal asymptote at y equals 0. So what's happening to y? And y is being multiplied by -2, but since y is equal to 0, nothing is, the horizontal asymptote is not going to move. So let's see where our new points are. 0, -2, 0 minus 2 is -2, and 1 times -2 is -2. So the point 1, 0, 1 is now at this point has been shifted, right? And it's now at -2, comma -2. How about the second point, 1 comma the base? 1 minus 2 is -1. 3 times -2 is -6. So -1, -6. Now remember, a is negative, so I've been flipped. The horizontal asymptote didn't go anywhere. And I'm still going to slide swoosh. Label the points. And label the horizontal asymptote. You don't have to label the new y-intercept on these. You only have to label these two, where the point 0, 1 went and where the point 1, 3 went. So remember, exponential functions, domain, always all round numbers. Sorry. Oh, rats, my graph went away. That's okay. You have the graph. The domain is all round numbers. The range this time, because I was flipped, is less than 0, and the horizontal asymptote didn't go anywhere. All these are true. No x-intercept. Oh, I didn't. I said you didn't have to label the y-intercept, but I'm asking for it here. That's okay. How do you find a y-intercept anytime, any place, anywhere? Plug in 0 for x. So I get -2 times 3 squared, which is -2 times 9, which is 18. Exponential functions have no local or absolute max or mins. This exponential function, because a was negative, was not increasing but was decreasing over the domain. And again, we had it look like this, right? So that was, this one was concave down over its domain because of the flip. The asymptote was still at y equals 0. Right? -2, 2. What was it? -1, -6. All right, let's do the natural log one. Remember, don't let e throw you. Okay? Now, if I wanted this +4 to be an x issue, I would have to put parentheses around it. Since no parentheses were there, you do not assume they're there. This is ln of x plus 4. So remember, for natural log, we don't have the point 0,1, we have the point 1,0 because of the inverse situation. We don't have the point 1 comma b, we have the point b comma 1. And now what's happening? Well, to x, nothing happened, right? Nothing happened to x. There was no multiplier on front, right? The multiplier was only 1, so the only thing happening to y was adding 4. And then don't forget, log functions don't have a horizontal asymptote, they have a vertical asymptote, and it's not at y equals 0, it's at x equals 0. But since nothing happened to x, my vertical asymptote stays in the same place. So my new points are 1 plus 0 is still 1, 0 plus 4 is 4, e plus 0 is still e, 1 plus 4 is 5. So plot the point 1, 4. And plot the point e comma 5. Remember, e is a number a little bit, almost a 3, but a little bit shy. And then go up 5. And label it. E comma 5. And then draw the log shape. And remember, the log shape also slides along the asymptote and then swooshes slowly. The domain of log functions always starts at the vertical asymptote. The range, though, is all real numbers. Remember, it's the opposite of exponential functions. Yes, log functions are a function. Yes, they are one-to-one. And yes, they're continuous once the domain starts. The x-intercept I'm going to leave for a second. The y-intercept is y equals ln of and plus, look at the graph, right? There is no y-intercept. Just like exponential functions, there is neither an absolute nor local max or min. This log function is increasing over its domain. I just did something wrong. Do you see what it is? The log function is increasing over its domain. That's why you do domain first. The domain is not all real numbers. The domain is x is greater than or equal to 0. I'm sorry, greater than 0. Decreasing, and look, apparently I can't spell decreasing or increasing. Oh, I think I fixed it on your handout, didn't I? Decreasing, never. This log function is concave up over its domain. And is never concave down and has a vertical asymptote at x equals 0. Since I asked for the x-intercept, how do you find an x-intercept? Anytime, any place, anywhere. Right? An x-intercept, you plug in 0 for y. How do you get x by itself? You have to undo logs. Undo logs with exponents, right? Dipsy doodle this. Remember that's e. E to the negative 4 equals x. When y is what? Yep, 0. So your x-intercept is e to the negative 4, which of course you can write like this. Get out your calculator and see what that number is. You know, do e to the negative 4. If you don't have a calculator, you just leave it like this. If you have a calculator, it's 0.018. Which makes sense, doesn't it? Look how close that is. Again, let me repeat. For these graphs, if you are only asked to graph, let's say I was not asked for a characteristic list. I was only asked to graph. For these transformations, you do not have to graph and label the x and y intercept. You have to graph where, for exponentials, where did 0, 1 go, and where did 1b go. For logs, and where did the horizontal asymptote go, if anywhere. For logs, where did 1, 0 go, and where did b, 1 go, and where did the vertical asymptote go. If I ask you for characteristics, and remember I have to ask, do not generate a characteristic list if I don't ask. Then yes, you have to find the x and y intercept, but you just do what you always do for x and y intercepts. Plug in 0 for x, plug in 0 for y. Okay? All right. Now, this could be on the non-calculator portion, right? It will be on the non-calculator portion. You need to be able to graph these without your calculator. Next, though, exponential modeling problems will be on part 2. They will be with your calculator, so please do get your calculator out and take these notes. Exponential modeling problems are not going to have shifts on them. They're just going to be a times b to the x, the ones that we're going to do. Okay? Make sure to define your variables. That's old news. This time, though, when you get the points out of the problem, remember when we were in the linear unit, you looked for 2 points so you could make a slope. When you were in the quadratic unit, you looked for 3 points, or you looked for 1 point in the vertex so you could solve for the dilation factor. Here, you need to look for the 0 point. And what I mean by that, since this is exponential modeling, right, you're looking for the 0, a point, right? What do I mean by that? Well, look at how this is going to be, right? What happens when you plug in 0 for x? You get a. So a must be the start, or the initial value, or the 0 point. That's what I call the 0 point. I call it a 0 point because when x is 0, you always get the dilation factor. So this is kind of a silly question. Right? If you plug in the 0 point, you're always going to be a. That's why solve is in quotes. Then you have to find a second point. So you do still need to find 2 points in these problems. It's just sometimes the 0 point is in words, like it says at the beginning or initially there were. That's the 0 point. You need to be able to store values in your calculator. Okay? All AP and IB exams say you are expected to maintain degrees of accuracy within a problem, but you can round at the end, right? And when you round, right, to 2 or 3 places past the decimal. The AP exam always asks for 3 places past the decimal. So here's the, let me make sure to go back to that. And don't forget that you have your homework is right here. Okay, so there's 1, 2, 3 problems for homework. The book, again, the directions in the book are a little, you know, if you try to follow what the book says, it might confuse you. So that's why I have, like, do these problems like I did, okay? Like I'm modeling for you. Modeling, haha. All right, so here's our exponential modeling problem. So this is actually called a consultant, right? This is what consultants do. So I'm figuring projected costs for the newest movie currently being filmed. Notice what I made. Now, I'm not going to bold this on the test. You find that when filming started, that's what I call the 0 point. When filming started, time was 0 and money was $1.6 million. So let me write X is time. What's my time measured in? And Y is millions of dollars. After 2 months, $5.4 million had been spent. Assume that cost varies exponentially with the number of months it takes to film. So cost Y varies exponentially with months. We have the 0 point. Oh, define variables. I did that already. This is the general exponential equation. They asked me for the particular one. What that means is use the second point along with the A value, right? When you have the 0 point, the Y value, or the new Y-intercept, is 1.6. But I don't know the base, but I do know that when filming had been for 2 months, I spent $5.4 million. Now, I know this is a squared. I kind of regret making it a squared because I'm going to do this problem as if I don't know square roots, okay? So the first thing I'm going to do is divide both sides by 1.6. I don't care what that number is. I don't need my calculator yet. 5.4 divided by 1.6 is equal to b squared. Don't take the square root, because what if that was cubed, or what if that was 2/3, right? What did I teach you to do? How to undo an exponent. Now, yes, I know that square root, but again, what if that exponent had been 2/3, or what if that exponent had been, 4/7? You can raise each side to the reciprocal power and isolate b. I'm going to store this in alpha b on my calculator. Okay, so get your calculator out. On your home screen, type parentheses 5.4 divided by 1.6, close the parentheses, and raise that to the 1/2 or 0.5 power, and store that in alpha b. Of course you can store it in alpha A if you want. I just thought it was cute to store it in alpha B for the base. So my B value is approximately 1.87. Again, give me 2 or 3 places past the decimal. So what is my particular equation then? So my particular equation is y equals 1.6 times 1.87 to the x. Now ask yourself a question. Is the money growing over time, or is it decreasing over time? It's growing, right? So does it make sense that a base being greater than 1 means that this is a slide swoosh situation, right? Doesn't that make sense? I feel good about myself. So now the next questions are plug and chug, right? If it took 5 months, is that an X or a Y? So show me that you're using your model to plug in 5. And then go to your calculator and say 1.6 parentheses. Don't use 1.87. Use alpha B raised to the 5th power. And you get 33.5-ish units. $1 million to make a movie that costs 5 months to film. Number 3 is just a repeat, right? American Pie, wah wah. Y of 7. And I got about $113 million. That's from Austin Powers, the whole $1 million thing. Funny movie if you hadn't seen it. So this one I just do y of 1, right? Hello units. What are my units again? Time has to be in months. So how do you take 1 week and turn it into a month? Now, I don't care. 28 days, 31 days, 30 days. I don't care. Just show that you understand that you have to take 1 week and turn it into some unit with months. I say that's about a fourth. 1 week is about a fourth of a month. So I got 1.8-ish million dollars. Okay? So how about the last one? If the movie Dipsy-Doodle, ha ha ha, cost $25 million, what did they give you? $1 million. What unit is that? X or Y? I'm sorry, what variable? That's my Y. Show me that you plugged 25 in for Y. Then do some algebra. Divide both sides by 1.6. Uh-oh, X is up in exponential land. Who gets it down? Logs, right? Transform that into a log equation, right? Who's my base? Logs are exponents. I'm going to base this into base 10. And when I use my calculator, I am not going to type 1.87. I'm going to hit log 25 divided by 1.6, close the parentheses, and I'm going to divide that by log alpha b. Okay. So let's graph now. This is swell math, right? You know, that's all great, but if you have, remember you have a calculator. So if you have a calculator, there would be an easier way to do this, right? So please get your calculator out and type into y1 1.6 times alpha b to the x. Now before you hit graph, think about the numbers that you need to have on your window, right? Look, you're by the time x is equal to 7, you're up to 113. So you might want to make your window, your y max, go to like 150. Right? And make your x max go to 10. Make your x min 0, right? Now maybe make it -5. I don't know, just so you can see. And look at that picture. So turn this over to draw your graph. I guess it doesn't. Oh, it doesn't let me write on there. I'll have to do it on here, huh? Just do my graph here. Please label your axes, time. It's a terrible, terrible graph. Time in months, cost in millions. My equation is y equals 1.6 times 1.87 to the x. This one I do want you to label the 0, right? This happens to be the y-intercept, but it's where 0, 1 went. There was no shift on the horizontal asymptote. And then you have the point 1 comma b. And you slide to the y-intercept and swoosh up. Okay? So, since you have your calculator, the easier way to answer this question, you still have to show me 25 is equal to 1.6 times 1.7 to the x. You still need to show that to me. But you can use your calculator, right? And into y2, graph the line y equals 25. And use your intersect function. I know that scale's not right, but go to y2, hit y equals 25, graph it, and then do your intersect function, right? And I got 4.5. 4.5 what? That's an X, right? So years? No, 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 no. Months. All right? So again, the book problems are just like this. I don't remember if the book problems ask you to graph, but I will. Okay, I will ask you to graph. So, so make sure that you practice the graphing your exponentials the way that I've modeled here for you in class. Okay? Have a great one, and I will talk to you soon. Bye-bye.